The intersection of these three lines forms a planes which are termed to be as coordinate planes. When you add the line segments AB and BC, you will get the line AC. So thus it shows the 3 points lies on the same line and hence the points are collinear. So we can see here equation of x-axis are y is equal to 0 and z is equal to 0 because the coordinates of y and z are 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Department of Mathematics. In this session, we are going to learn the new chapter, three-dimensional geometry. So we have learned the determination of a point or distance of a point from a line or whatever in two-dimensional plane, that is x and y axis with respect to the coordinate axis. Now here we are looking up towards the three-dimensional geometry. So here in this session we are going to study about the coordinate planes in three-dimensional geometry as well as the distance formula in three-dimensional plane. Now let us consider three perpendicular lines that is mutually perpendicular to each other. So when three mutually perpendicular lines intersect with the same origin, so let this be origin. So the intersection of these three lines forms a planes which are termed to be as coordinate planes. So any plane determined by the pair of axes. So it may be z and x, it may be z and y, it may be x and y. So any plane determined by the pair of axes or nothing but the coordinate planes. Now certain points to be noted in three-dimensional geometry is any point on three-dimensional axis is represented using an ordered triplet, that is x, y, z. That is the distance of a point with respect to x-axis, y-axis and z-axis. So the next thing is the coordinate of the origin is always determined in the form of 0, 0, 0. And any point on the x-axis, you can see if I take a point A on the x-axis, here the coordinates of y and z will be 0. Similarly, if you take a point on y-axis, here the coordinates of x and z will be 0. Any point on z-axis, the coordinates of x and y will be 0. Other than this, rest of the points are determined in the form of an ordered triplet. And when you are talking about the planes, so when I talk about the planes here, so a plane is an area determined by the pair of axes. So any point which lies in xz plane, so this plane, xz plane, then its y coordinate will be 0. So that it will be in the form of x, 0, z. Any point on xy plane, suppose this is the point n, you can see here, this point n is on xy plane. So in that case, z coordinate will be 0. Similarly, any point lies only on yz plane, then its x coordinate will be 0. So we can see here, equation of x-axis are y is equal to 0 and z is equal to 0 because the coordinates of y and z are 0. Equations of y-axis in three-dimensional geometry is x is equal to 0, z is equal to 0. Equation of z-axis is x is equal to 0 and y is equal to 0. Similarly, equation of xy plane is z is equal to 0 and any point on xy plane has its z coordinate as 0. Similarly, equation of yz plane is x is 0 and has its x coordinate 0 for any point. Similarly, equation of zx plane is y is equal to 0 and any point on this plane will have its y coordinate as 0. And any other point on three-dimensional axis will be represented in the form of P of x, y, z. Next is the term octants. What do you mean by octants? So when two perpendicular planes meet with respect to origin, the entire plane is divided into quadrants. So 4 parts. That's why we call it as a quadrant. But when three mutually perpendicular planes meet, whose intersection is at the origin, so then the entire plane is divided into 8 parts, which is called as octants. As we have learnt the signs in quadrants, that is x positive and negative depending upon the direction. So here x and y coordinates are positive. Here x is negative, y is positive. X, y both are negative. Y negative, x positive. So these are the signs in different. That means any point on this different quadrants will have the respective sign. So in the same way, any point which lies on any one of the octants, it will have its own sign with respect to x, y, z values. And the sign of these octants is shown in the following table. So I told you we have octants. So that means the entire plane is divided into 8 parts. So therefore 1, 2, 3, 4, 5, 6, 7, 8. So if a point lies in the first octant, then it has x, y, z values as positive. If a point lies in the first octant, then its x, y, z are positive. So for example, 1, 2, 3. So it's a point where x, y, z values have the coordinates as 1, 2, 3. Now if a point lies in second octant, then its x value is minus, whereas the y and z values are plus. Similarly, if you go on, the last octant, 8th octant, any point which lies on the 8th octants will have a sign in the form of x, minus y, minus z. So this x, y, z may be anything whose values with the positive and negative signs with respect to y and z. So easy to remember the x coordinate and y coordinate and z coordinate and write down all the octants. So just write x coordinate as plus, minus, minus, plus, plus, minus, minus, plus. Next for y, plus, plus, minus, minus, plus, plus, minus, minus. For z, 4 plus and 4 minus. So then you can find the point lies in the particular or the required octant. Name the octants on which the following points lies. So here we have the points here. I need to find out the octant here, respective octant. 1, 2, 3. So all are positive in first quadrant, in first octant. So therefore it belongs to the first octant. 2, 4, 5, obviously first octant. Minus 3, 1, 2. So x is negative, y and z are positive. So just see, x is negative, y, z are positive. So therefore this point lies in the second octant. Next we have x and z as negative. So see, so x and z are negative, y is positive. So therefore it lies in the sixth octant. Next we have y negative. So we can see the fourth quadrant, y is negative, x and z are positive. So therefore here it is fourth quadrant. Similarly, we have 4, minus 2, minus 5. X is positive, y and z are negative. So x is positive, y and z are negative, which means 8th octant. So therefore here we write 8. So next we have x and y positive, y negative. So x and y positive, y negative. That means the point lies in the 5th octant. So here we write 5th octant. Next, minus 4, 2, minus 5, x and z are negative, y is positive. So x and z are negative, y is positive, which means it lies in the 6th octant. So here we write 6th octant. Next, x is negative, y and z are positive, which means it lies in the second quadrant. Next, we have xy negative, 6 positive, which means it lies in the third octant. Next one is all are negative. So all are negative in the 7th octant. So therefore, we'll write here 7th octant. So these are the position of the points in the respective octants. Next we have a distance formula. Show that the distance between the points x1, y1, z1 and x2, y2, z2 is given by x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this, until here we have learnt the distance formula in two-dimensional geometry. Here we have an additional coordinate with respect to z-axis, which can be termed in terms of z2 minus z1 whole square. Now consider a point P and Q. Let P has the coordinate x1, y1, z1 and Q has the coordinate x2, y2 and z2. So here we are supposed to calculate the distance PQ. So what I am doing here, I am consider a three-dimensional axis with respect to x, y, z, where O is the origin. So let the line segment be PQ. So draw a perpendicular PM and QN with respect to XY plane. So the first thing is draw PM and QN perpendicular to XY plane. So when I am talking about X and Y, so M will have the coordinate of X1, Y1 and N will have the coordinate of X2, Y2. So the distance MN can be given by square root of X2 minus X1 whole square plus Y2 minus Y1 whole square. Next, draw PR perpendicular to QN, that is equal to MN. So draw PR perpendicular to QN. So when I draw PR perpendicular to QN, we get PMNR as a rectangle. So this implies PMNR as a rectangle. So when it forms a rectangle, we can clearly see the distance PR is same as the distance MN and the distance PM is same as distance RN. Now, here I said this is a perpendicular. So consider the triangle PRQ. So by Pythagoras theorem, we can write PQ square is equal to PR square plus QR square. So now this distance QR is obtained by subtracting QN with respect to RN. Now since I said PRNM is a rectangle, instead of PR, I can write MN square. And QR can be written as QN minus RN whole square. So here, this QN is nothing but Z2 and RN is nothing but Z1. So this is the distance which is equal to PM, which is the length Z1. So therefore, MN from this equation can be written as X2 minus X1 whole square, Y2 minus Y1 whole square without the square root. So here I can write X2 minus X1 whole square plus Y2 minus Y1 whole square. And here I can write this as Z2 minus Z1 whole square. So this is PQ square. Now therefore PQ or the length of the PQ can be written in the form of X2 minus X1 whole square plus Y2 minus Y1 whole square plus Z2 minus Z1 whole square. So this is the required distance between the points P and Q. So we'll take problems on the distance formula. Find the distance between the following pairs of points 1, minus 3, 4 and minus 4, 1, 2. So we need to take the difference with the corresponding coordinates under the square root. So here the distance, we can also use the short letter D or the capital letter D. So which can be written as X2 minus X1 minus 4 minus 1 whole square plus 1 minus of minus 3, Y2 minus Y1, which becomes 1 plus 3 whole square plus Z2 minus Z1 whole square under the square root. So which is 5 square 25, 4 square 16, 2 square 4. So which will be root 45. We can also write this as 3 root 5 units. Next one, minus 3, 7, 2 and 2, 4, minus 1. So distance D is equal to 2 minus of minus 3 becomes plus 3 whole square, 4 minus 7 whole square, minus 1 minus 2 whole square under the square root. So 5 square 25, 3 square 9, 3 square 9. So this is equal to root 43 units. Next one. Show that the points minus 2, 3, 5, 1, 2, 3, 7, 0, minus 1 are collinear. So if 3 points lie on the same line, so let me consider this as point A, B, C. We can calculate the distance between AB, BC and AC and show that they are collinear. How? With the help of distance formula. So if I show that the distance AB, the distance of AB plus distance of BC is equal to distance of AC, then the 3 points lie on the same line. So first let us calculate the distance between these 2 points, then this, and finally these 2 points. So let us see how we will get the sum. So let me calculate this by taking point A as -2, 3, 5, B as 1, 2, 3, and C as 7, 0, -1. So distance AB is square root of 1 minus of -2, which becomes +2 whole square, plus 2 minus 3 whole square, plus 3 minus 5 whole square. So which is equal to 3 square 9 plus 1 plus 4. So which is root 14. Next we'll calculate the distance BC. So distance BC is 7 minus 1 whole square plus 0 minus 2 whole square plus -1 minus 3 whole square under the square root. So 6 square 36 plus 4 plus 16. So which is root 56. So which can be written as 2 root 14. Next we have distance AC. 7 minus of -2 becomes 7 plus 2 whole square, 0 minus 3 whole square, -1 minus 5 whole square under the square root. So here 9 square is 81, 3 square is 9, 6 square is 36. So which is root 126, which can be written as 3 root 14. So clearly if you consider this as equation 1, equation 2 and equation 3, if you add 1 plus 2, this is equal to equation 3. That is the value 3 root 14. So we are getting AB plus BC is equal to AC. So when you add the line segments AB and BC, you will get the line AC. So thus it shows the 3 points lies on the same line and hence the points are collinear. Next we have verify 0, 7, minus 10, 1, 6, minus 6, 4, 9, 6, minus 6 or the vertices of an isosceles triangle. So before showing that the required result, first we need to recall what do you mean by isosceles triangle. So isosceles triangle means the triangle whose 2 sides are equal. So when we are calculating the sides, obviously we need to use the distance formula here. So when we get 2 distances are equal, which represents the sides of the triangle, then we can prove that these are the vertices of an isosceles triangle. So let this point be A, let this point be C, and let this be C. So first let us calculate AB, distance AB. So 1 minus 0 whole square, 6 minus 7 whole square, minus 6 plus 10 whole square under the square root. So 1 plus 1 plus 16, which is equal to root 18. Now similarly, let's calculate BC. So we have 4 minus 1 whole square, 9 minus 6 whole square, minus 6 plus 6 whole square under the square root. So we have 3 square 9, 3 square 9 plus 0, which is equal to root 18. So when I say root 18, this can be written as 3 root 2 units, 3 root 2 units. So obviously the sides AB is equal to BC and hence ABC forms the vertices of a isosceles triangle. In the same way, to show that it is an equilateral triangle, take one more side AC and show that AB is equal to BC is equal to AC so that they can represent vertices of equilateral. And if you want to show that it is the vertices of a right angle triangle, calculate the distance of all the sides and apply the Pythagoras theorem. That is AC square is equal to AB square plus AC square and hence verified so that you can recognize those are the vertices of right angle triangle. Next we have find the equation of set of points which are equidistant from the point 1, 2, 3, 3, 2, 1. So let this be point A and point B. So let our required point be x, y, z. So given distance AP is same as distance BP. So let us square it on both sides. So when we square both sides, we can write the distance formula without using square root. So now let us apply AP. So this becomes x minus 1 whole square, y minus 2 whole square, z minus 3 whole square. This is equal to x minus 3 whole square, y minus 2 whole square, plus z plus 1 whole square. We can cancel y minus 2 whole square on both sides, expand the remaining term. So x square plus 1 minus 2x plus z square plus 9 minus 6z, x square plus 9 minus 6x, z square plus 1 plus 2z. We can cancel x square, z square on both sides. Similarly, we can cancel 9 on both sides. We can cancel 1 on both sides. So we are left with minus 2x minus 6z is equal to minus 6x plus 2z. So shift everything to the left hand side. So we get 6x minus 2x as 4x. 2z when it comes here, it becomes minus 8z is equal to 0. Or we can write x minus 2z is equal to 0 or x is equal to 2z. So this is the required equation for the set of points which are equidistant from point A and point B. So thus in today's session, we have learned what do you mean by coordinate planes with respect to three-dimensional axis, as well as we have learned to calculate the distance between the points and other related terms. I'll meet you in the next session with the new concept. Until then, keep watching, keep learning and keep exploring. Thank you.